Hello everyone, myself Srivalli here from Sri Venkateswara College of Engineering, Bengaluru, pursuing in third sem CSE Chanakya. Subject Operating System. The topic in operating system is comparative and analytical network for choosing the best suited SDN operating system for cloud data center. SDN. Its full form is Software Defined Networking. Introduction. SDN paradigm introduces a flexibility in data networks as network devices comply with MOS instructions by separating the control and data planes. In particular, switches in the data plane perform the packet forwarding related functions as determined by the control plane. The so-called MOS runs on computer hardware, and the control plane represents the business logic in SDN paradigm as it the controller of network functions. Specifically, it determines how to handle the incoming data packets using the protocols such as OpenFlow. On the other hand, SDN paradigm also provides a network abstraction for applications at the management plane so that the operator can efficiently perform the different network tasks. Software-defined networking paradigm, which NOS is the best suited for CDC. What are the functional and non-functional specifications to be verified for this use case? How important is each of the specifications to answer the first question? Software-defined networking. Here we can see the applications as a control plane, which is the SDN controller, and the data plane, SDN for switches, and the pool of application servers. There are many invoices, and the development frequency is rapid. Therefore, selection of appropriate invoice for CDC requires an analytically comparative study. The selection of the appropriate MOS for the aimed use case profoundly impacts the offered services as it is the control plane in SDN paradigm. This is a study expected to help the researchers and the operators in the field to transform from the traditional network of SDN paradigm, identifying the most common open source for MOSs and determining the appropriate MOS for CDC. Characteristics of cloud data center. Nowadays, cloud computing drives most business and shapes a new era of technology delivery. Cloud computing provides a different services such as software, storage, and virtual resources. So it abstracts the technical complexities and it eliminates the cost and the risk associated with hardware maintaining and acquisition. In recent years, SDN has been employed in CDC since SDN provides a central control of the network. SDN-based center network is DCN is preferred to the traditional DCN since it can be improve the DCN efficiency. Non-functional features. There are maybe scalability, security, easy to use and maturity, and interoperability and availability. Scalability. Now we can discuss the scalability. ONOS, ODL, and Tungsten are more scalable than the other NMOSs, since they support the distributed model in which multiple NMOSs instance can either interoperate simultaneously. However, ONOS can assign the segments of wide area network or DCN to specify the instance to mitigate the instance load. ONOS employ the Atomics database to store the network information, which is also used for coordinating between the instances. In particular, ONOS represents a logically centralized control plane in the infrastructure might consist of multiple domains, which one NOS instance for each domain. Here, we're giving the scalability information how it consists of ONOS, ODS function, how it is very scalable. Easy to use and maturity. In terms of modularity, new modules can be added to all NOS feasible either as a Python component or Apache Karaf. However, ONOS provides an ANG management system that abstracts a data modeling. Details of applications and device drivers by generating ANG model Java objects corresponding to device and application schema so that the business logic will be the sole concern. Hence, it can be seamlessly support an interface like representational state transfer, network configuration protocol, and extensible markable language, etc. ONVOS and ODL have the richest documentations. In addition, ODL and ONVOS have the fastest update frequency and the most varied and the numerous applications. But Tungsten provides a richer GUI than other NVOS configuration terms of keywords. IP addressing, ports, policies, etc. can be depicted defined using the base GUI. Interoperability. Tungsten ONVOS and the ODL provide a simple mail transfer protocol as a management protocol which provides so many facilities in environments such as CDC. In relation to the South API control protocols, ODL provides a model-driven services adoption layer MDSAL, which simplifies the communications between ODL modules and the data plane through the available soundboard APIs. By supporting the user-defined payload formats, including the payload serialization and adaptation. Availability. Availability has been boosted in all NVOS except POX by applying the master-slave model. The continuous mirroring operates between the master and the slave instance, so the slave takes the responsibility upon the master failure. However, since ODEL maintains the virtual network information on ODL level in case of multiple CDC sites, non-disconnected ODL instance can provide the inter-site services during the network disconnections, where ODL instances employ the AMQP to communicate with each other so that no need to share information between instances. On the contrary, ONVOS instances present a logically distributed control plane by sharing the information using Atomic's database. Functional features, they are namely fault verification and troubleshooting, packet forwarding technique, and the virtualization. Fault verification and troubleshooting. The most outstanding troubleshooting capabilities have been found in ODL and ONS as well. ODL provides a diagnostics framework to report the status of ODL itself by performing the health of the system, and it additionally triggers the alarms. On the other hand, ONVOS provides a framework to break the routing loop, routing black holes, and the application conflicts. On the other hand, ONVOS provides a framework to break the routing loop, routing black holes, and application conflicts. As well, ONVOS integrates a service like CPMAN14 and Ganglia 15 to maintain the information of the ONVOS state. Packet forwarding technique. For the sake of improving the availability and the performance, ONVOS balances the load between the instances in a cluster. Tungsten balances the load among the virtual resources by providing the load balancing as a service by employing the different drivers, such as proxy 18. On the other hand, ONVOS improves the QoS by providing SDN, which manages the flow setup by considering the information such as the path requirement, QoS and service level agreement (SLA). Virtualization. Virtualization. In relation to virtualization, all NVOS except POS integrate with the OpenStack orchestrator, support the virtual local area network. Moreover, Tungsten, ODL and ONVOS support the virtual extensible LAN and L3 tunneling. In this context, ODL manages the overlay tunnels established within a transport zone using the VXLAN, generic routing encapsulation and generic protocol extension for VXLAN, and MPLS and over GRE, MPLSO GRE. Besides, ODL provides L2 L3 tunneling network, address translation, NAT, and access the control list. Services for virtualizing sources using Neutron Northbound API, which communicates with the ODL driver in OpenStack. On the other hand, ONVOS provides a tenant network virtualization services for CDS provisioning using L2 VXLAN or L3 journey. Furthermore, ONVOS provides the L2 L3 tunneling and NAT provides using virtual stack. OVS 19 is the compute nodes and provides a horizontal scalability of the gateway that connects the virtual network with the outside by BGP. Here we can see the non-functional requirements like scalability, which is 10.67%, security it is 10.6%, easy to use 3.22%, and the maturity is 4.09%, and interoperability is 10.67%, and the availability is 10.67%. In the easy to use development and usability, development is 2.41% and usability is 0.8%, which is modularity is 0.97% and GUI is 0.2%, development community is 0.48% and the documentation is 0.8%. North API is 0.97%. In maturity, the update is frequency is 3.07% and the application availability is 1.02. In interoperability, which is the management protocols, is 5.34% and the control protocols is 5.34%. In functional requirements will consist of fault verifications and troubleshooting, packet forwarding techniques, virtualization, traffic protection solutions, in which fault verification and troubleshooting is 8.33% and packet forwarding is also 8.33%, virtualization is 25% and traffic protection solutions is 80.33%. In which the packet forwarding techniques is load balancing and quality of service. In it, load balancing is 4.17% and quality of service is 0.17%. In virtualization, the overlay networks and the isolation. In overlay networks is 12.5%, isolation is at 12.5%. Conclusion. We presented the best suited NOS to use in CDC by assessing the specification of 6 NOSs. According to the criteria imposed by the cloud data center requirements, BISA will represented to extend that each NOS meets the criteria. To best of our knowledge, that this is the first study in the literature tackling such a problem. For this, we determine the requirements of CDC by investigating the characteristics of such an environment. Then we classify the CDC requirement of functional and non-functional criteria based on which were inspected the specification of the investigated NOSs. Thank you.